So in this video we're going to introduce the Roman abacus and the Roman counting board, and we're going to do a couple of adding sums and a couple of subtraction sums. This is a reproduction of a Roman abacus, reproduction of a surviving abacus from the Roman world. This reproduction comes from the Roma shop. They haven't paid us to make this video, we're just gratefully acknowledging our sources. We have grooves with beads that move. On the right hand side we have two columns of grooves that Romans used for fractions. We're going to ignore those for this video. Starting with this one and moving over to the left, we have long grooves down at the bottom with 4 beads each, and we have short ones at the top with 1 bead each, and in the middle we have Roman numerals for 1, 10, 100, 1,000. That's not the only way you can do a Roman numeral for 1,000, and it may not be the one you're familiar with, but that also says 1,000, and then 10,000, 100,000 and a million. In this long groove, each bead stands for 1, in this one 10, in this one 100, and then 1,000, 10,000, 100,000 and a million. And up here, this bead stands for 5, this one stands for 50, and then 500, 5,000, 50,000, 500,000 and 5 million. We don't have numerals at the top telling us the values of these beads at the top, but the principle is every time you move from one of these long grooves at the bottom up to a short groove at the top, the value of the bead in your short groove is 5 times the value of one of those beads down at the bottom. Now, to show that a bead is in use, we need to move it into the centre of the abacus. So if we want to use the abacus just to count, we're going to go 1, 2, 3, 4, and then 5 is up here. But if I want the abacus to say 5, I need not only to move that bead into the middle, but to remove those 4 as well, because if I forget to remove those 4, that will say 5 plus 4, that will be 9. But this is 5, and then I can go 6, 7, 8, 9, and then 10, 11, 12, 13, 14, 15, 16, 17, 18, and so on. We know that Romans also had counting boards. Those are boards with movable counters. They sometimes used pebbles, they sometimes used beans or lupin seeds. We have chickpeas here. We don't have a surviving counting board from the Roman world. We have some references in literature and at least one representation in art, but we don't know quite as much about the counting board as we do about the abacus. We suppose that the counting board worked more or less like the abacus. This is a reconstruction of a Roman counting board, again from the Roma shop. It's got long rectangles down at the bottom for ones, tens, hundreds, thousands, and a little square up here for a 5, a 50, a 500 and a 5,000. They haven't given us a numeral up here for 5,000, probably because the Roman numeral for 5,000 is not very familiar in our world, but the principle again is if you go from one of these long rectangles up to the short space above it, then the value of a counter up here is 5 times the value of a counter down below. Now, in order to show that a counter is in use, we need to put it on the counting board, and if we don't want it in use, we need to remember to take it off. It's not like the abacus where the beads are always there somewhere and we need to worry about whether they're in the middle or at the outside. So if we want to use the counting board just to count, we're going to go 1, 2, 3, 4, and then 5 is up here, and then 6, 7, 8, 9, and then 10, 11, 12, 13, 14, 15, oops, stuck in my fingers, 16, 17, 18, and so on. This is a fairly simple counting board because we haven't got columns for fractions over here, and we haven't got columns for numbers bigger than the thousands over here. You could make a counting board that had those features, but because it's quite easy to make a counting board, if you were a Roman, you might scratch one for yourself on a piece of broken pottery, or perhaps draw one on a wax tablet. It's quite likely that they didn't make them bigger or more complicated than they needed to for a particular purpose. And in the Reading Ancient Schoolroom, we've mostly been using counting boards like this because most of the sums we've been doing will fit on a counting board like this. Now, Eleanor, how do you write 12 in Roman numerals?
XII.
And how would you represent 12 on the counting board?
With one bean under X and two beans under I.
Good. And how would you write 17 in Roman numerals?
XVII.
Good. Now suppose we wanted to add 12 and 17 on the counting board. What we do is we first put one of the numbers we're interested in on the counting board, and we've just done that for the 12, and then basically we're going to leave that number there and we're going to add the counters for our other number. And look, could you add counters for 17? That's XVII. Excellent, and that's our answer. Now, what number is that?
29.
Good. Now, is XXVIII how we usually write 29 in Roman numerals?
It's not how I usually write it.
How do you usually write it?
XXIX.
Good, because in our world, we usually write 29 in Roman numerals as XXIX because we write the 9 part as IX. And Romans often did that too. But they didn't always do that. Quite often, they used this other system where the 9 part is VIII and 29 is therefore XXVIII. And if we want to do arithmetic, we have to use that system. That's to say, we're never going to put a smaller number in front of a larger number because arithmetic just won't work in Roman numerals if we do that. So we're going to never put a smaller number in front of a larger number. As far as I know, we don't have an ancient text that tells us that, but it just won't work otherwise. Now let's do another adding sum. Shall we do 62 plus 54? Eleanor, would you like to write 62 and 54 in Roman numerals on your wax tablet and perhaps explain what you're doing?
So 62 is 50, 61, 1.
Great.
Now 54, I would normally write LIV, but am I right that you would like me to write LIIII?
Yes, very good, because we're never going to put a smaller number in front of a bigger number. So not only will 9 be VIII, but 4 will be III, and therefore 54 will be LIII. Very good. And we've been finding in the Reading Ancient Schoolroom that it's useful to have a written record of the sum we're doing, because if we get to the end and we forget what sum we're doing, it's hard to be sure if we got it right. So we're again going to start by entering one of those numbers on the counting board. Let's start with the 62. And Eleanor, what happens if you add counters for 54?
So you put 1 here and 4 here.
Great. Now, very good. We've now added 54, but we've got more counters up here than we ideally want, because ideally we never want more than one counter in one of these little squares up here. Think about the abacus. On the abacus, we've only ever got one bead in these small grooves at the top. And down here, we've got more counters than we really want in one of these long rectangles. Again, I believe fairly strongly that the counting board is meant to work pretty much exactly like the abacus, and on the abacus you couldn't move more than 4 beads into the centre on one of your long grooves because you haven't got more than 4 beads there. On the counting board, it's physically possible to have too many beads temporarily in some of these spaces. If that happens, it's not the end of the world, but we need to tidy things up. Eleanor, how could we tidy up those 2 50s up there?
Well, 2 50s are 100, so you could take away those 2 beads and put 1 there.
Very good. And what about here? How could we tidy that up?
Well, you've got 6 1s, and 5 1s equal 5, so you could put 1 under the V and take
Very good.
That's
And
five
what's that number now?
116.
Good, and that's our answer. Very good. Now, some people believe that Romans actually worked this way on the counting board, that they allowed themselves temporarily to have too many counters in some of those spaces, and then they tidied things up. There's an ancient biography of the Emperor Caligula where there's a bit about how Caligula used to use brutal language. And there's a comment he's supposed to have made when he'd signed a list of prisoners he wanted executed. And some people interpret that comment as him saying, I'm tidying up my counting board, I'm getting rid of the unnecessary counters on the counting board. I don't actually believe that interpretation of that comment, and I believe fairly strongly that Romans never really put more than one counter in one of these little squares or more than 4 in one of these long rectangles, because I think that the counting board and the abacus were meant to work very similarly, and that if you learnt to use one of these pieces of equipment, the skills would then transfer quite neatly onto the other one. So I think what they did is actually simplify as they went along, and let me show how that would work. So here's 62 again. I want to add 54. I'm going to start by thinking I want to add 50, but before I add a second counter there, I think, no, that would be too many counters there, but that would get me to 2 50s, that would be 100. So before adding a second counter, I avoid doing that by removing that counter and putting a counter there. And then I can start adding 4, 1, 2, and then before adding the third one of those 4, I think, no, adding a third one, that will get me to 5. 5 is up there, and then I can add the fourth one there. Let me do that a little bit quicker because it flows a bit better if you go quicker. So I want to add 54, that's 50, 1, 2, 3, 4, and our answer again is 116. Now let's do a subtraction sum. Eleanor, would you like to choose two numbers a number you'd like to subtract from another number?
Shall we subtract 51 from 62?
Great. So let's enter, would you like to actually write 62 and 51 in Roman numerals? Great, so let's start with 62. Now subtracting is the opposite of adding. Rather than adding counters for 51, we now want to take away counters for 51. And 51 is Li. As you've said, can you remove counters for Li?
That's the L, and that's the I.
Great, and that's our answer. And what is that?
11.
And that's 11. Excellent. Now let's do a slightly harder one because subtraction gets a bit more interesting if it's a little bit harder. What would be a slightly harder subtraction sum?
Shall we subtract 54 from 62?
Great, so let's stick with the 62 and 54 theme. So let's enter 62, but this time rather than adding 54, we're going to subtract 54. And then what happens if you try to subtract 54?
Well, that's a 50, and that's 2, but now we're in a bit of a trouble because I haven't got another 2.
You haven't got another 2. And what could you do if you haven't got another 2 you can take away there?
Well, I happen to know that 10 minus 2 is 8, so I could just take the x away and add VIII.
Great, and that's what I would actually do, and we can come back to that, but there's something else that you might do, particularly if you're happy to have too many counters on the board at a time.
So I might say 110 is 2 5s.
Right.
And do that. And then I might say 1 5 is 5 1s. And do that. And I've still got 10.
Right.
And now I can take away 2.
Great. And then your answer is 8. And that will work. I don't believe the Romans quite did it that way, but I can't prove that. So again, I think that they never put more than one counter up here or more than 4 up here. Simplifying as we go along, here's our 62. Again, I'm going to take away 54, that's 50, and then take away 1, 2, and then want to take away 2 more. I know that taking away 2 is the same as taking away 10 and adding 8, and I think they just used that little bit of knowledge there. That brings us to the end of this video. This is who we are. Thank you very much for watching, and in the next video we're going to demonstrate multiplication using the same equipment.